Welcome to Catalyst Conversations. For today's episode, we focus on engineering services for noise control solutions, not just as a product, but as a decision making tool. We'll discuss why acoustical, noise, vibration, and seismic decisions are often unclear early in a project, what risks those unknowns create, and how engineering analysis helps teams reduce rework, improve accuracy, and meet demanding schedules, especially in high stakes environments like data centers. We are joined by Thomas Yuschak, who's the Vice President of Engineering at Kinetics Noise Control, Joe Florer, the General Manager of Air Solutions at McMillan James, and Logan Herkomer, Director of Sales, HVAC Market at Kinetics. And now, let's get started with today's conversation. All right. Well, thanks everybody for joining us. I'd like to start by having each of our guests do a brief introduction of themselves, and then we'll get rolling further into the topic for today. I'm going to go around here. Tom, we'll start with you.
Okay, thanks, Adam. My name is Tom Yuschak. I lead engineering at Kinetics Noise Control. Over the last several years, we've been building a pretty strong engineering services leg that does everything from pipe stress to seismic design to vibration analysis. And I'm excited here to talk to you about engineering services.
Great. All right, Logan.
Thanks, Adam. I'm the Director of Sales for HVAC Market, which includes vibration isolation and seismic. And I've been in some form of the building materials industry for many years, a couple of decades even.
All right. And last but not least, Joe.
Thanks, Adam. My name is Joe Florer with McMillan James Equipment Company in Texas. I'm the general manager of our air distribution and acoustic solutions division. And I have a really strong interest in engineering services, especially in the data center space. Not just because Texas is a hotbed of data center construction activity, but because this particular niche of our design, of the design process and our industry is really growing. There's a ton of value in engineering services and delegated design and things like that I think there's a big opportunity for everyone who's involved in these kind of projects to understand what value this can really bring to their project.
All right, great. Well, thanks, guys. Appreciate that. Get us started. I think this is an episode we're really excited to go through because I think each of you has a lot of interesting takes and experience and value to bring to this. And just talking about engineering services, there's so many different layers and angles that we can go through. But I think part of it would be helpful to start by talking about some of the decision-making issues and difficulties that may be present for architects and designers and even engineers early in the decision-making process. So I think to get us started here, and Tom and Joe, I'm kind of looking at the two of you to start, but Logan, please jump in with any thoughts you have as well. But based on your experience, where do you most commonly see difficulties and challenges early for those types of groups when they are selecting noise control solutions? And why do you think it's so difficult for them to make those types of decisions with the confidence needed to be sure of what they're doing?
Well, from my perspective, a lot of times early in the process, there's incomplete technical information. And sometimes what happens is everybody's moving forward, assumptions get made, and those assumptions may or may not be based off reality. They might be more based off rules of thumb or what they've known in the past. And those can end up getting kind of locked in. And that's where it can become a problem down the road, where if you have earlier type input from engineering to take some of those unknowns and turn them into knowns, then you can kind of drive forward with a lot more confidence that you're going the right direction and that you're going to get to where you need to get to more efficiently.
Yeah, thanks, Tom. That's a good point. I would add to that a little bit of context around this data center space, especially now with the advent and growth of AI and AI's usage that's really permeating all aspects of our lives now. That's the simple fact is that the data center construction cycles are unbelievably compressed. The speed to market expectation of clients like NVIDIA and OpenAI and Amazon AWS and these big hyperscale clients, or even smaller clients, that they cannot access data storage and processing fast enough. So the construction life cycles are so unbelievably short that the time given to the design professionals and specifiers, especially for these huge projects, is like minimal. Layer that on with the actual availability of massive amounts of equipment from the primary suppliers for cooling or for GPUs or whatever. These companies have to buy billions of dollars of infrastructure years in advance before they even know where a data center is going to be located, before they even own the property, the land where it's going to be, before they even have a full plan for how the data center is actually going to be powered. But the only way that they can supply, that they can hope to have the equipment there in time for the construction, is to pre-purchase all of it. And what that does is that pushes the specifiers into corners, because all of the equipment is pre-purchased, even though it might not necessarily be well suited to that project site, that locale, that location or whatever. And the designing specifiers, because their timelines are so compressed, and they're all scrambling to try to figure out how to make this equipment that's been pre-selected for them work, certain things end up getting pushed down the line because there's simply not enough time to address all of it. And one of those things, while it might seem menial, is the design of the vibration isolation systems in order to preserve the long-term rigidity, robustness, lifespan of the building itself and the equipment. And there simply is not enough time up front from the specifier's perspective to put in, to do early design for themselves. It is essential for a lot of them to bring in professionals who can help consult and just help keep the guide rails, keep the train on the track, keep the guide rails in place. Even if you don't know where the building is going to be, if you have an idea that we're going to build some data centers in California or in Utah or in North Carolina or Texas, and you know it's a seismic zone, or you know that there's wind concerns because it's mountainous and we're going to put it in a valley area, so there's just air velocity concerns, things like that, like it can really help drive decision making that at the beginning of a project might seem menial and like it's not going to have a big impact. But when you get down to the end of the project and an installing contractor has to make decisions to preserve the life cycle of equipment, or to ensure that piping isn't going to crack and break and create a massive insurance liability for all of these billions of dollars of equipment that were purchased, it can have a huge impact. Even small minor decisions early in a project.
Yeah, I think that's really important what you mentioned, and kind of leads into our next point. Well, we see this in data centers, a lot, with having to comply with standards, being like city noise ordinances and things of that nature. And so when we talk about engineering services and getting these things aligned, one of the topics I think that comes up is that this can really be a risk mitigation tool. So my question for you guys is, at what point do you see where engineering kind of moves from being a nice thing to have, and then is really showing up as a real risk management necessity?
So I guess from my perspective, rules of thumb really start to break down as the systems start to get larger, as they start to become more complex, as the speed to which you need to get them up and running increases. If you simply go by rules of thumb or trying to not get some good engineering consultation in up front, you risk being over conservative. And over conservative doesn't work well. It tends to make things too heavy, too expensive, and it also oftentimes misses the problem entirely. So for example, if you have like large pipe runs and the supports for those pipes are laid out and there's thermal activity there, you can get yourself a long way down the road by looking at some critical runs up front to make sure that the support spacing is adequate, that you're not overloading the structure, to get an idea if your layout is going to, how much growth is going to, and flexibility you need to build into that system. Waiting too long until things get locked in tends to cause a lot of panicked frustration at the end to do rework which slows everything down to a halt and drives cost up. We're bringing in these services early, just to help answer these questions that are critical at the time and check them off the list so people can move forward confidently. Goes a really, really long way in just making the project run smooth and the handoff run smooth, from trade to trade and from building to building and things like that.
I would add to that. I agree with everything that Tom said. There's a risk mitigation here that is in many ways incalculable, because once again, the speed that the design professionals have to act on these projects and the speed at which they have to make decisions does not leave space for redesign. If there are issues with the system, if there's issues with the layout, or if there's issues with product selection, it just gets kicked down the line. And at the end of the day, our overall goal that all of us should have is delivering a long-term, well-functioning building to the owner. They deserve to get a high-quality, long-term, robust delivered product in exchange for their investment. And it, again, I will keep coming back to this. Simple decisions at the start of a process can have huge repercussions and implications later down the line. If we are trying to make decisions about how these systems will get connected to one another, or how they will be protected from a potential seismic event or a potential insurance level event, a leak, some kind of act of God, some kind of flood, some crack or something, if we're waiting until we're coordinating BIM, we're laying this out with a contractor, it might be too late, because the size of the mitigating solutions, they might not fit, because we had to cram so much in place because no one had a seat at the table to raise their hand and say, hey, in order to make this work, we need this much space. Please make sure that space is allocated for us, right? Risk mitigation is the name of the game. And at the end of the day, delegated design, engineering services, it means a lot of things. Us, myself, Logan, Tom, Adam, making a recommendation on a simple product to use or a simple technology to consider early on in a project can have huge, huge implications down the line in really positive ways. That is delegated design. That's helping avoid liability. That's helping the customer ensure that they're not setting themselves up for a problem down the line when there's not going to be any time to fix the problem.
I would just add really quick to that. I think you can pay for analysis and delegated design early, or you can pay for change orders late, right? That's kind of the risk. But there's a second piece to that as well, is when Tom's team gets involved in a design early in the game, you're not just looking at large pieces of equipment that have a 2-year lead time. You can actually avoid risk on other material lead time when you get an engineering team to look at what's required. Because if everybody knows what really will delay a job is, no one ever looked at product A that we need to complete a job, and now I have to have it in a week. Well, is it even available in a week, right? So even lead time on product and material you need for a job is part of the risk mitigation in this. I would say I think that engineering has a cost to it, but removing uncertainty and getting a more solid lead time to finish a project is worth far more than any of the costs that the engineering team is going to bring to the table up front early in a project.
Yeah, I would also add that in that bucket of risk mitigation, there's also this allow options, right? And options that lead you to a better solution, where better might mean not as complex or less cost. And an example that I have from one of your projects, Joe, is we got some piping that came in, and the material for that piping was copper. And copper has a much lower allowable stress. It has a lot of thermal growth to it, and it's subject to the wind forces. well, we could use copper piping. That was fine, but this was also outside. It was going to result in a lot of restraints on that piping because of the wind forces that it would be acting on it. Where what we were able to do is give an option of saying, well, instead of copper, if you use steel piping, it might be a small delta for the material itself, but it removes all these restraints. It makes installation and upkeep much easier than they would be otherwise. So risk mitigation to, help avoid errors, but also in just making the project run smoothly, keeping it as simple as possible by saying, what's the best choice here? And how do we actually demonstrate in a defensible way that it is the best choice?
I think that's a great call. That's a great point, Tom. At the end of the day, there are more data center projects needing to be constructed than there are contractors capable of completing that construction. The only way this is getting done is if we simplify as much as humanly possible, and we simplify starting early in the process. It is never fair to expect a design professional, a specifying professional, an engineer, an architect, or whomever, even if they've been in industry for 40 years. It is never a fair assumption that they know everything, that they're going to be an expert at everything. And that's okay. There are niche professionals that are out there to help with this kind of thing, whether it's in a formal consulting capacity, whether it's in a capacity to where there's an exchange, there's a contract and an exchange of dollars or whatever, whether it's intended to actually defer formal liability or it's just to help the designers make better decisions earlier on. And all of it is intended to make this easier to construct because engineering has to accelerate these project timelines. It just has to. There is no if, and, or but. If we want to keep this rolling in the US, we have to make it easier to build these buildings.
Speed comes from clarity, Joe.
Yes, absolutely. Like Logan said, invest up front and remove uncertainty, or invest at the end when there's change orders and no one has time to fix it. So the workmanship at the end of the day, no matter who the contractor is or how good they are, if everyone is rushing to get off a project to get to the next one because there's no time, who knows what's going to happen? Things might pass final inspection and they'll be fine right now, but next year, who knows?
Yeah, and one of the components of this, as you guys have talked about, is all the various players in this, all the various teams and groups are going to be involved in this in a project from start to finish. Obviously, it's communication, coordination become paramount throughout the project. I'm interested to hear more about, with your experience, where do you see that coordination break down, and then how does engineering help to kind of keep everybody together and aligned throughout the process?
Well, from my perspective, I guess where I see things tend to break down is kind of at that boundary layer between trades, between specialties, and what engineering can help do is kind of form that bridge. So, for example, let's say that a structural layout is done by the structural guys based off all the dead loads and everything like that, and it's designed great structurally, but they don't have the right information to take into account the seismic loads or the thermal growth of the pipe and what kind of extra loads are going to be put on the structure. So there's kind of, from their perspective, they see only what they see, right? Instead of having necessarily the grand picture of the entire system coordinated across all the different disciplines. And by having kind of engineering in the design with them to help coordinate that, it builds those bridges and makes the unknowns visible to all of them. So then they can just get tackled one by one, answer the questions, and get support earlier rather than later. So kind of a key thing there really is the best time to get engineering involved is when there's still a little bit of flexibility, right? If you can, when you get the right amount of input to make an informed decision, and that allows you to make a decision to maybe change things a little bit that take you on a much better path that's going to get you, to where you need to go much quicker.
Excellent. One of the things that we love to do on this podcast is talk about real world examples. I think it's a great way to relate to people in the industry, talk about unique circumstances that may come up. So, Joe, I wanted to point this in your direction to start, just based off your experience. But you've talked a lot about data centers. Obviously, it's a huge topic and something we see all the time now and projects we're involved with regularly. But would love to hear you kind of talk us through a specific data center project where you saw how engineering was able to make a meaningful difference.
Thanks, Adam. So I could definitely speak to this. Obviously, we can't get into too much of specifics just because all these projects are very closely guarded and the IP is protected, right? But that's okay. There's a lot of lessons learned that I can share based on a couple of projects that we're working on and we've worked on. The interesting thing about these data centers that we're seeing these days is they're often being constructed in parts of the country that are less occupied, where there's not very much infrastructure, and therefore they're being constructed in like large campuses, complexes, where a single building is being replicated multiple times. Maybe there's 2 or 4 or 8 or 10 or 16 buildings of similar size or identical size that are quote unquote duplicates of one another. They're never true duplicates, but they're close. Mm-hmm. And they're doing this because they're also having to construct power stations. They're having to construct wind farms. They're having to construct some kind of method to actually provide the electricity for these facilities. And it is very rare for subcontractors, not general contractors, but subcontractors, to have the manpower to do more than a few of these buildings at once. So what happens in this situation is you have a single contractor who maybe has 2 of the 8 buildings, and then another contractor has 2, and then another contractor has 4. It's all the same general contractor. It's all the same design team, the architect, the specifying consultant, whomever, and the same GC or developer or whatever. But the contractors themselves are different. And what happens in the typical process now, where liability gets deferred, and it gets deferred down the line, it's designed into the project documents and specifications. Okay, final design to be completed by general contractor or by installing contractor or something like that. So the decision-making part of this kind of thing, especially where vibration isolation, acoustic mitigation is concerned, gets pushed down to the installing contractor. Well, now we have a situation on a single site for the same GC, the same owner. You have multiple contractors who are making decisions on how to interpret a specification the best way they see fit. And now you don't have consistency across the projects, across all the buildings. And really what happens here is it creates challenges for the vendors, for the general contractor, for the owner even, because at the end of the day, consistency is key. These facilities are very remote, often. They're hard to get to. They have to be serviced continuously. There's so much equipment out in these facilities that there's people that basically have to live out there servicing the equipment. And it's incredibly important that the equipment itself is as consistent as possible, that the installations are as consistent as possible. Because in building A, maybe all of the control valves for the piping system are easily accessible because that contractor on that building decided to put them in a location that was accessible. But building B, who has to be serviced by the same team of service folks working for the owner or whomever, decided to put them somewhere else where it was maybe cheaper to put them in, or some other trade got in there first because there's a timing issue and they can't access the valves cleanly or conveniently. This creates a huge problem on some big sites. And because they're remote, there's a big mobilization and there's all this frantic chaos when the project is being completed. And then once the contractors are done, they're gone. And it's super expensive for them to send people back out. It's super expensive to send folks out for service calls. And because there's not consistency, it creates confusion. It creates the blame game. Oh, well, we really like those guys. So in building 4, we we thought it was them, so we called them, and we realized at the end of the day that, oh God, they didn't do that building. Okay, now we got to go to this other contractor. Oh, they did the building. Oh, but they don't have anyone available to come out. So how are we going to get this problem fixed? Because there wasn't consistency. We didn't know what was happening. We thought it was going to be this way, but that contractor made a decision that slipped through or whatever. At the end of the day, like these facilities, these campuses, they're so large scale that there's a like a ripple effect of impact after the project is even delivered, because there is inconsistency, right? And it's not anyone's fault necessarily, but even with just simple engineering involvement up front, creating consistency across a campus, that can establish and assist so much with mitigating those problems after the projects are delivered.
All right. Thanks for that, Joe. That's super interesting, and really appreciate you walking us through that process. One last question that I have for each of you here, and then we can get to some closing thoughts. But obviously covered a lot of different angles of this. But if you, for our audience, for architects, for engineers who are out there, if you could, have one major takeaway from today's conversation for them to know and walk away with, what would that be?
I would say engage engineering early if you can, while you still have flexibility in your design, rather than after problems appear. Of course, engineering can help resolve the problems, but it's a smoother ride if we get there earlier. Don't allow yourself to kind of subtly let assumptions turn into fact in your designs that will come back and haunt you later. Put those on the table, or let engineering address those and turn those into real technical decisions that has engineering backing and are defensible.
Joe, Logan, any thoughts there?
Yeah, I think, if you look at what we do as Kinetics, I think a great example in this is something like we have these outstanding acoustic products for industrial acoustics. And if you're building a data center somewhere where you're near a population or city center, you have to control that mechanical equipment noise. And so an acoustical engineer will come in, they'll specify our product, and it'll be the right product, a noise block wall around mechanical equipment. But how does that attach to this structure? What's the seismic code? What's the wind code for that? Right? And just something that, like Tom said, the trades all layer on top of each other. And if you don't look at that, then at the end of a job, you're trying to solve an issue where you need to look at the structure, you need to look at the steel, you need to look at the concrete of a building. And that's the type of thing that I've seen in the past be overlooked. And the other thing I think is that, like what Tom said, is it never gets cheaper to solve an engineering problem. As the building goes, it only gets more expensive. And, in the past, data centers used kilowatts of energy, and now they use megawatts. I mean, the cooling it takes, the pipe it takes to cool these buildings, the water that it takes, these are really complex mechanical systems. They create a lot of noise and vibration, and it's only getting more complex the larger they get. And so to have somebody design that early on in the game, what I like to refer to as a bowl of spaghetti on the plumbing set of a data center, it really takes someone like Tom and his team to do a great design and give you the confidence to complete the project on time and hopefully efficiently and within budget as well.
So I'm going to do two things. I'm going to add to Logan's statement. I'm going to go back and continue answering. Then I'm going to go and continue answering the multidisciplinary trades thing, and then I'm going to finish this question. So just a heads up.
All right.
So Logan, totally agree. I would even go further than just saying this. These are measured in megawatts now. These are actually gigawatt. They're measured in gigawatts. These data center campuses are gigawatts in size, which is just insanity, right? And to your point, all of this equipment, the spaghetti bowl of piping, creating a bunch of noise, all of equipment manufacturers can't even predict how 100 of their products in a row are actually going to impact the vibration or the noise level of a property. there's no way that they're going to be able to predict it because it doesn't necessarily act in a linear way. Two chillers right next to each other does not mean that the sound is twice as loud. Four chillers next to each other, it might be 10 times as loud. It's logarithmic, it's not linear. It's pretty unpredictable, especially for design professionals who are moving fast, who are in our minds, okay, you put two of these products there, it's going to be twice as loud, or whatever it is, right? It's unpredictable, which is why it's so important to engage experts at an early level. Okay, going back to the multidisciplinary thing. So coordination at the GC level is critical because even across buildings, if you have one trade having differences, yes, that creates problems. But then you have all your different trades that might require isolation type equipment. The electrical folks might need stuff. The switchgear might need stuff. The telecom folks might need stuff. The cable people might need stuff. Like electrical conduit doesn't necessarily expand and contract. You have to accommodate that. You have to plan for that. And it just because we're focused on mechanical because water breaking out of a pipe is a huge problem. I mean, you break an electrical line and there's an arc. That's a huge problem, guys. Fire suppression, that's a giant problem. It's the exact same thing on the building expansion joint side. Like you put in building expansion joints so you can accommodate for the expansion and compression of the steel or the concrete or whatever. Like that is every single trade has to deal with that. And if you aren't looking at it holistically from a high level, there's going to be breakdowns across the trades in their approach and how they handle it. And it is going to create an issue in the medium or long term, or maybe even the short term. Labor warranties are a couple years max at data centers. On a standard project, it's a year. I mean, is it worth risking an issue in the future without and not making a little bit of investment now? That's up for the design professionals to decide, right? I would say one thing for architects, engineers, specifiers who are working in this space to take away from this conversation is that there are lots and lots of skilled professionals out there who are well equipped to help you early on in these projects. And just because you engage a design professional does not necessarily mean you're locking yourself into working with only them. It does not mean you're locking yourself into financially committing to a certain person. Now, there are lots of people who will offer, who are well equipped and skilled, who are able to offer guidance, advice, direction, recommendations based on code standards, experience, etc., that can be very, very helpful, but you don't necessarily lock yourself in with them. There is still a situation where you go and there's competitive bidding. There's still a situation where just because it's a skilled design engineering service, it does not mean that it has to be overly expensive. It's not cheap to do this. The processing power, the design intuition and skill, all of it is very specialized. And it's very important that when you're finalizing documentation, you're finalizing a delegated design analysis, you're finalizing a thermal expansion analysis or something like that, that is completed by a professional who can stamp it and has the insurance to support their decision making in their analysis and data. But that can happen later on in the project. Help us help you make sure that when we get to that point, it doesn't have to be more expensive than it needs to be. Help us help you make good design decisions early on about what products to expect, how much space to allow for them, what the weights might be, what the general recommendations or needs or requirements or integrations across trades. Help us help you. No commitment, no financial commitment. You don't have to pay me to make recommendations for you. I would love to do that for you because at the end of the day, if our owners who are paying for these buildings get better quality buildings and better quality service, it elevates the entire industry. And it allows us to deliver higher quality buildings for everyone. And at the end of the day, this is a competitive world. It's a competitive industry, but all of us want all of us to should want all of us to succeed, because it reestablishes the value that we all bring.
All right. Awesome. Well, thanks for that. Those closing notes. I think this is a good spot for us to wrap here. So I just want to thank you guys. It's awesome having each of you on. Hearing your experiences and your expertise in this matter is wonderful, and I think it's going to be really beneficial for all of our audience today. So thanks a lot, and can't thank you guys enough for being here.
Thanks, Adam. Thanks, Logan. Thanks, Tom. I enjoyed this.
Appreciate it, guys. Me too.
Take care.
Thanks. Thank you to our guests for joining today's episode and sharing their insights. And thanks to you, our listeners, for hearing another episode of Catalyst Conversations. Be sure to subscribe and leave a review, and we look forward to having you join us for more discussions featuring the experts driving the future of acoustics, noise control, and vibration management. Until next time, thanks for listening.